Buoyancy. As Archimedes discovered, any object immersed in a liquid receives a thrust upwards equal to the weight of the liquid displaced. This force, called hydrostatic thrust, therefore opposes the weight of the object. Imagine taking a plastic bottle for mineral water with an external volume of 1 litre. When it is completely immersed in water, it displaces 1 litre of water. Since a litre of fresh water weighs 1 kilogram, according to Archimedes' principle, the hydrostatic thrust towards the surface will be exactly 1 kilogram. What happens to the bottle? It depends on what it contains. If you filled it with an element heavier than water, it will weigh more than 1 kilogram. The weight is greater than the hydrostatic thrust, and the bottle will start to sink to the bottom. This condition is defined as negative buoyancy. If you have filled the bottle with water, it will weigh 1 kilogram. So the hydrostatic thrust equals the weight exactly. This condition is called neutral buoyancy. The bottle can stay still at any depth. If instead the bottle is empty, that is full of air, it weighs just a few tens of grams and will therefore return to the surface immediately. This condition is called positive buoyancy. The variation in buoyancy is one of the most important factors which the freediver must learn to live with. Do not believe that it is easy to manage, because it goes from positive to negative during the dive with the increase in depth, and from negative to positive during the ascent. The pressure variation causes an inverse variation in volume, but varying the volume changes the quantity of liquid displaced, and consequently the buoyancy, while the weight stays the same. Ultimately, the condition of buoyancy varies. Let's take a practical example: the neoprene wetsuit. Thousands of gas bubbles are enclosed within the neoprene foam. The bubbles are subject to the pressure increase at depth, and their volume is reduced. A practical consequence of this is that the thickness of the suit is reduced as you go deeper. At 10 meters, the absolute pressure is doubled and the volume of bubbles has been halved. This means that the volume of liquid displaced by the suit is almost halved. Almost, because the neoprene is incompressible. Therefore, the hydrostatic thrust decreases and buoyancy becomes negative. On the other hand, with the neoprene wetsuit, you assume a condition of very positive buoyancy on the surface. To descend without too much effort, you have to wear weights.